So, hi everyone, my name is Boris and I live on a farm called Asimha. It's a permaculture farm. Have you ever heard about permaculture?
No. Yeah.
Alright, permaculture. Asimha, yeah, it's over there. We're sort of an eco-oriented community, just like this kibbutz. The previous group knew what a kibbutz was. Do you know what a kibbutz is? Alright, so this place, Kramim, you probably heard the history from the nice lady that gave you the tour. Few eco-oriented people came to live in here a few years ago, and this place changed vastly over that time. And one of the things that changed in here is the attitude towards the environment, towards this place and other places as well. Today we're going to talk about a grey water system, which is something that I believe is really important. We do that on our farm, they do it in here, and I want to explain why it's so important. Take a look around you, right? Basically what you're seeing is desert. I don't want you to stand, but you'll believe my word that just over there is a big forest, the Kramim forest, and the place is named after the forest, right? If you look over there, then you can see desert again, right? So how come we have forest over there, a few trees over here, and the desert just behind us? Now same altitude, same rainfall, same everything. And it is exactly, that forest was planted, and so how come there are no trees everywhere? Because trees can survive in here, obviously, right? Israel is located at a subtropic climate, right? Subtropics means lots of rainfall. Usually subtropic places have, monkeys screaming at the treetops, not desert. So let's go back to biblical times. We're located near a place called Beersheba. Beer in Hebrew means a well, 7 wells. You probably know the biblical story about one of the guys with his herd, and he was looking for a place to let his herd to have a sip of water. You heard about it? We don't have time for that. So basically, in biblical times, all of Israel, north to south, east to west, was with a lush green forest. So we're in the desert now. Any ideas where the desert came from? How? Anything? Sorry?
Global warming?
Way before global warming. Way before global warming. In biblical times. What happened in biblical times in Israel? War, exactly. By we I mean human beings, done that. Lots of different cultures invaded this place, and we human beings need wood to build the warships. We like to conquer places, exploit the resources, so basically we build great big houses from the newly found riches, and then we need firewood to heat the place in winter, and etc. etc. And an ecological system can behave like a snowfall or rocks that falling from a mountain. If you push a rock at the wrong place, it will drag, a big fall along with it. So there's a turning point when you cut the forest. Basically, when you reach a certain place, the whole thing dies, right? And we try to reverse that. And we try to reverse that in a few different ways, but one of them is the obvious one: conserving water. We can use our water not only for washing dishes. The same water can be used and reused again. Let's talk a little bit more about water. you've been to the Golan, right?
Yes.
Probably a few days ago. Have you seen the Hermon Mountain?
Yeah.
Right. So that's the place that we have snow in Israel. The highest rainfall, most of the snow. And have you visited a few rivers? Had a nice swim?
Whenever we fell in.
Whenever we fell.
Fell in. Good as well. So, small country, right? Rivers over there, desert over here. When you've been there, probably all of the trees are green, the grass is growing, maybe still has flowers, right? So, it's obvious how you get water. How do you get same water in this tap? That's easy, guys. Come on. Lots and lots of pipes. So the water from the let's start in the winter. It's more romantic, right? Snowflakes are falling on, and they have bodies, and they, I don't know, listen to reggae music and party in the winter, and people skiing, and it's all a happy, cold place. Spring comes, the ice and the snow melt, and the rivers are filled with water, right? Where do the rivers go? You've been there. It's not a test, not an exam. Okay, the big lake in the north, come on. Big lake.
Oh, yeah.
Kinneret, okay? So all of the rivers go to the Kinneret, and that's our big water reservoir. We do have a little bit of groundwater, but most of the water comes from there. And then the Rastafari snowflakes, right? They meet big pumps, and those pumps, they get the water. How much did it take you, like driving in a bus to reach this place from there? You went through Jerusalem.
From Golan, yes, like 3.5, 4.
Let's say 4 or 5 hours. That's that's considered a long drive in Israel. So, bike work from Kinneret comes to the center of Israel. From there to Tel Aviv, to Jerusalem. From there, further south, Ashkelon, Ashdod. Don't know if you've been there. From there, Beersheba, and from there, over here. And that requires a huge amount of energy in the form of electricity. You need lots of energy to cast the steel for the pipes. And basically, you know how many liters of water are being flushed down the toilet when you do that thing?
5.
That's 20 liters of fresh drinking water. That's more than enough for a person to survive for a day, right? And where does that water go when you flush the water?
The desalination plant?
Maybe. Sewage, right? And the sewage goes to the desalination plant, or maybe we skip the desalination plant, and where does that go?
Ocean.
Exactly, fishes, guys. So basically for this system, the rainwater treatment system that we're going to talk about today, in order for it to function, you need natural detergents and biodegradable soaps and etc. Have you ever seen such a thing? A brown lump of soap with no smell, no red color, no green color, no lemon smell, like the real thing, soap. Almost extinct from this world, right? So please understand that red soaps are made out of oil, right? There are no red soaps in nature, and there are no hair conditioners in nature. There's no such thing as silicone. All of those things are not biodegradable, and we're sending that to the fishes because we think that fishes are far away, right? They don't live on land. Let them take this stuff. So it is a good idea to use biodegradable soaps anyway, but especially when you have a rainwater treatment system that uses biological means to treat the water. Alright? So we've talked about where the water comes from, we've talked about the current situation. Yes?
Do you take any water from the Mediterranean Sea? There's a big coast let's see, do you take it and desalinate it? Use
No,
just
no,
take
we
it
do
there?
that in a lot. We do desalinate water in a lot. But bear in mind that once there was a forest over there was rainfall.
What was the question?
Do we desalinate seawater? And the answer was that only in Eilat. And once, long time ago, we had a forest over there, and we had rainfall, and we didn't need to desalinate everything. We had rivers back then. Okay, so now we understand the importance of reusing the water, and I want to get a little bit into the topic of the grey treatment system itself. By the way, did you ever heard the term grey treatment system?
Yes.
Okay. Alright. So maybe the guys that did can tell me the difference between black water and grey water. Anyone?
Gray is from like the shower, and then black is from the toilet. No.
Exactly.
Oh, yeah.
Please you tell me. The water that comes from the garbage disposal thing in the sink, is it black water or grey water? Not really. It's black water, and the definition is the amount of organic matter in the water. Feces are organic matter. Not a nice one to deal with, but it will return to the soil, meaning it will decompose, and one day will be nutrients for plants or algae or whatever. So it's considered black water because it's hard to treat. It has lots of organic material. Garbage disposal thing, it takes, I don't know, a carrot or a cabbage and shreds it to tiny pieces. Again, same problem. Grey water is water that doesn't have that much organic material in it, and that's why it is easy to treat it with quite simple means. And that's what we're going to see all probably now. So do you want to come with me to the sun for a few minutes? Sure. Boris. So I need a brave volunteer.
Yeah, I'll do it.
You're a brave volunteer.
I'm most stupid, but yeah.
Please, in order for me to demonstrate this system, I really want you to wash this cup.
You don't make dishwasher, right?
Yeah, it's a make-believe wash, but do keep in mind that if you have a drink of water and you're not infected with herpes, there's no need to wash it with soap, right? It makes sense.
Oh,
So,
wow, I got to tell you.
I drank.
So, should I just wash it? Or?
Please do, yeah, make believe. But we need.
I don't first you
It's
rub
not
it.
the best way to conserve water, but we do need it for the demonstration.
Thanks, Trevor.
Oh, happy days. Okay, so all of the water treatment systems, all of the sewage treatment systems, basically everything that recycles water depends.
You want me to turn this off or keep it going?
It's okay, that's enough because it's full. Please don't, careful, don't drown there. So, yeah, so all of the water treatment systems, sewage treatment systems, everything that cleans water up is based on one principle, that we're not alone. And in not alone, I mean we have a vast array of basically, we'll call them bugs for the sake of this conversation, but many microorganisms, and those bugs, their role in our ecological system, in the ecosystem, is to recycle everything that's biodegradable. If it's hair, if it's biodegradable soap, if it's this shirt that I'm wearing, the banana peel that I ate this morning, and even me, will degrade with time, and there are bugs to do it. So even if we treat sewage, we utilize the same bugs. Of course, because we use green soaps and bleach, we do need to get the chemicals out of the water, but as soon as we get the chemicals out of the water, it's exactly the same principle, whether it is made, whether it's a big sewage treatment plant, or a few barrels or buckets, or a matchbox, I don't know, same principles, right? So this water treatment system is basically designed, it's scaled for home use. No big buckets, no salmon, nothing fancy. The principles are really simple. 4 stages. The first stage is called a solid separator. Easy, right? This thing catches all those peas in mayonnaise from our salad and those little chicken pieces. We don't want them in the system. Why? Because the bugs can't digest coarse matter. Basically, big things need to be composted. So this is a wet composter. You probably all know about composting, right? That's like common knowledge these days. So we have straw, which is carbon-based material, and we have our peas. You know, when you compost, you put your food scraps, you cover it with newspapers or leaves or anything that contains carbon, and it degrades into finer materials that plants can later on utilize. So that's wet composting. Here we put wood chunks, straw, I don't know, sawdust, newspapers, whatever. Basically, it's a filter, it catches big pieces. From there, the water goes to the next stage. Now, this bucket is called the anaerobic stage. Anaerobic, we have 2 kinds of bugs. The first kind really likes oxygen. It needs oxygen to thrive. This is called aerobic, air, right? The other kind is anaerobic. They really don't like air. They like dark places. They like heat and so on. So this bucket is usually covered, right? Now, for the sake of the demonstration, we open the lid. So this is the anaerobic stage. We breed anaerobic bugs in here. This thing also doubles as a fat separator. A fat separator, an interesting principle, really easy to grasp. Do you see the pipe work in here? Yeah. Can you all see? So there's the entrance pipe, right? And it goes, let's say, till here, half of the bucket. And there's the exit pipe, which also is connected to an L-shaped thing, right? So the water enters to the middle of the bucket and exits from the middle of the bucket. We call it a fat separator. Can anyone tell me what happens when you put oil on water?
Oil rises.
Exactly, it rises, it floats. So all of the oil then rises, all of the sand sinks, and from the middle we get clean water. Next stage, the aerobic stage. Now, how do we know that it's an aerobic stage? Easy. We don't have the pipe coming from the middle. We try to drip the water from high above. Now, when you've been to the Golan Heights a few days ago, you've probably seen a waterfall too. You've probably seen a few ones in your life, right? So, how does the water on a waterfall looks? Frothy, right? It's bubbly. Bubbly means oxygenated. That's what we're trying to do here. Sometimes we put a few water plants in the gravel. This water plant basically gave its life back to the creator. So, but let's imagine that there's a water plant sitting here. Now, water plants, their role in nature basically is to oxygenate water. Well, they have flowers and they're really beautiful, but they take oxygen and through their roots pump it.
You want me to stop? Or? Dude, I made this thing my way.
That's shiny, man. You're all good. Thank you very much. So, sometimes if you have a bigger water treatment system, we can use an aquarium pump. When they treat sewage, they use, massive things. But the idea is to aerate the water. Now, the gravel, basically anaerobic bugs, they can float in water. They don't need oxygen. But these guys, they need surface area to grow up on. So we can use gravel or volcanic rock, which is even better, more surface area. And these guys just, wrap around the stones. If we'll dig a little bit, the stones will be a little bit yucky. Have you ever seen an aquarium? Right on the aquarium, you have this sludge. So this slime or sludge is the aerobic bugs. Okay, basically, peas are in the first stage, slowly they decompose, they degrade with the straw, they turn into less complex molecules. They go to the second stage, anaerobic stage, where the smaller molecules really get broken down. Sometimes this stage can be a bit smelly, the smell of rot. It's usually an anaerobic process, so we don't want to smell that. Then we get that to the next stage, which filters the volatile compounds, right, the smells, and those bugs degrade the organic molecules even further, and they degrade the molecules so much that they turn back into organic nutrients. So skin turns into fertilizer, hair turns into fertilizer, mayonnaise, McDonald's, fertilizer. Well, maybe not McDonald's, but mayonnaise.
That lasts forever.
In terms of water treatment, the first 3 stages, that's it. You don't need anything else. But we have another stage, and there was a pipe in here. Sorry, mate. Have a look. Do you still have it? Someone opening the pipe. That's a good. That's what I'm looking for. That's why we have the 4th stage. It's called the sand filter. A sand filter catches little tiny minute particles and removes the smells, the volatile compounds, even further. When water comes out of here, fresh. If this bucket would be, I don't know, 10 times bigger, you could even drink it again. But we are not going that far. We want to irrigate our garden with that. And in Israel, we irrigate with those things. Have anyone ever seen anything like that before?
Drip irrigation, right?
Drip irrigation. What else do you know about it? How does it work?
Basically, it conserves water because instead of just spraying water everywhere and letting it evaporate, it drips it in precise points so that the plant has enough water and it saves
Really
water
good,
too.
really good. Another important point is that when we irrigate, let's say with a garden hose, most of the water simply evaporates. It evaporates. Now, plants are like humans in the sense of water consumption. Let's say you have a beer, right? So, how do you drink beer in America? In liters, in pints?
I drink about a gallon.
Ounce.
Gallon?
I don't know, we got like, what is it, 16 ounces?
12 to 16.
Yeah, 12 to 16 ounces.
Okay, so let's call it jugs. Jug is a good word, okay? So you have a big, massive jug of beer, and can you drown it? I mean, go like, boom,
No, you can't chug it.
chug.
It'll take forever. And you'd probably like,
Okay, can you chug half of it?
yeah, I can chug half of it.
I
Maybe
think I can.
3/4.
Good. So you finished the first one. Can you chug another one?
Sure.
You don't know That's okay. Yeah, that depends if you're in college, probably. So plants are just like that. Basically, they can only drink, a certain amount at one time. So you need, if you want to irrigate them, you need to give them liquids, a tiny bit at a time. And that's why the drip irrigation has tiny little round heads on it, right? And those heads have sort of a plastic maze thing, right? And this maze slows down the water. The water comes at a high pressure, the maze slows the water down, and the water drips slowly, drip, 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 right? And we give the plant a chance to drink the water in slow sips, okay? A really delicate thing, really, really easy to plug, and that's why we try to use sand filters. Even in conventional agriculture, we always do put sand filters before the drip irrigation system. And that's it, folks. So 4 stages, let's wrap it up. Solid separator, anaerobic stage, which doubles up as a fat separator, aerobic stage, sand filter, plants, happy days, no more desert. Okay.